All right, number 17, this is a rate, time, distance question. This is how we're going to set up all the work rate and I guess the velocity type rate problems. This one's already partly set up. So they basically gave us, they said that let X be the uphill rate. So this person's hiking up a mountain. It's 15 kilometers up, and then it's another 15 kilometers down. So they gave us the distance that was fixed. Okay, so I suppose coming down, let's go ahead and start adding some things here. So coming down will also be 15. We could say that. We know that that's 15, right? And so how do we get, why did they put 15 over X? Well, that's the distance over the rate. Distance over rate is equal to time. So we're not going to put another variable and call it t or something like that. But distance over rate is equal to time. Rate is equal to distance over time. When we go down the hill, what does it say when it goes down the hill? Well, it says that they will go, the speed, the rate down the hill is going to be 1 kilometer an hour faster, right? So then if it's X going up, then going down, it's going to be X plus 1, right? What else does it say? It says that the speed is going 1 kilometer faster. It says that it will take 30 minutes less on the return trip. So going down would be 30 minutes less. So we know the time, this is the time going up, so going down would be 15 over X. But then we subtract, well, 30 minutes is half an hour. Since everything's in hours right now, because it's kilometers per hour, let's just subtract a half. That's a half. So that's a half an hour. So what does this mean? And so you might say, well, wait just a second. Why didn't you put 15 over X minus 1? Which is true. I could have put 15 over X minus 1. That's the time, but we don't know what X is. And then if we go and we say rate times time equals distance, we'll just get 15 equals 15. So that doesn't really help us. We want to combine something from going up and down. So we're combining that. All right. So whenever we have these problems, you're usually going to set up an equation where you have rate times time is equal to distance. We have the rate, we have the time, and we have the distance. So we could go ahead and set that up. So we should say that rate times time is equal to the distance, which is 15, right? Let's set that up. Change this. Let's go with this. Okay, so the rate is X plus 1. Okay. Times the time, which is a binomial here, 15 over X minus a half is equal to 15. Okay, so what is that again? This represents the downhill rate, the time going downhill, because remember it's a half an hour less than going up, and we know it's equal to a distance of 15, okay? And we said that X, once we find out what X is, that's the uphill rate. Ultimately, we're trying to find out how long the whole trip takes, but we can do that once we get the X value, which is the rate going up the hill. We know it's easy to get the downhill rate, just add 1. And then we can go ahead and make those calculations for the whole trip. All right, so one thing you could do is you could go ahead right now and multiply by the lowest common multiple of the denominators, or you can go ahead and expand. So I'm just going to expand it. It doesn't really matter which way you do it, I guess. So what I mean by expand is, well, this is 2 binomials, so we multiply here, then we're going to multiply here, and then here and here, right? We're familiar with that. So we're really just expanding this quadratic. We'll set it all equal to 0 like we always do, okay? So X times 15 over X, that's a nice one. That just comes out to 15X over X, which is just 15, right? And then X times negative half is minus x over 2. And then 1 times 15 over x is plus 15 over x, and then just minus a half is equal to 15. So if you look at either side of the equation, one thing we could do right away is subtract 15 to both sides of that equation. Let's just do that. So what I did is I minus 15 here. You don't have to really show that. You wouldn't have to. Okay, so now looking at everything here, I want to find out what the lowest common denominator is. What is the LCD? And we only have denominators of 2 and x, so that's pretty easy. They're both primes, just 2x. So I need to multiply all these parts by 2x. Okay, so I'm going to do that. Times everything by 2x. The nice thing is it's already set equal to 0 there. Okay, so when I do that, okay, I'm going to say, okay, well this 2 and 2 cancels. So I'm just going to have negative x squared. And then the x here and here cancels, so it's plus 30. Right? And then this 2 and 2 cancels here, so just minus x equals 0. Okay. Now I'm going to go ahead and times everything by negative 1. So I have x squared plus x minus 30 is equal to 0. So we've got to think about what, if they can factor this here. Let's try that. I need a product of negative 30, a sum of 1. So what are some of the factors of negative 30? 15 and 2 is not going to work. How about 5 and 6? So 5 and 6, and so we'd make it plus 5 and minus 5 and plus 6. So let's just test that. So x squared plus 6x minus 5x, yep. So we can say that x equals 5. Could x be negative 6? Can we go negative 6 kilometers per hour? No, that's not going to be. So forget about that one because we can't have a negative speed, right? So this is 5 kilometers per hour. And we said that that was the uphill rate. So this is up. So the downhill rate is going to be, we just add 1, so that'd be 6 kilometers per hour. The question asked how long the entire trip is. Okay, so that's pretty simple because what does it ask for? How long? Okay, so time is equal to distance over rate. So if we add the up and the down, so let's just write that out. We're going to do that. So total time, we'll say total time is equal to the time up plus the time down. Right? So the time going up is 15 over 5. That's a pretty easy one. Plus the time going down is faster. 15 over 6. So that would be 3 hours plus, if we simplify this, common factors 3. So 5 halves. So that's plus 2.5, 2.5. So the total is 5.5 hours. That would be our total time. So I should write that out. Total time, hike time, I guess, is 5.5 hours. Okay.